Alright, so as you read this question, I would ask you guys to sort of scan through the variables that are there, give it a read, and then jot down all the variables on the side. So starts from rest, accelerates positive 1 meter per second square, covers 100 meters. So because you start at an initial velocity of 0, it's implied that your displacement would be in the same direction as your acceleration. Does that make sense? You're not moving and then you accelerate a certain direction. You're going to displace that way. So then it says how long. So a good way to think about this is, of those 5, which one's not mentioned? VF. So you can't have a formula that has VF in it. So what does that leave me to? Okay, so that's not too bad, right? It's just a process of elimination. If you jot, and this kinematics style, it works all the time. Like, okay, these are the formulas you're limited to, these are the variables you're limited to, and then these word problems, like it's just a logic game. What can be difficult is if they give you some interesting scenarios that are tough to think about, and then, yeah. So anyways, what are we looking for? D is equal to VIT plus a 1/2 AT squared. So those are all vectors, but because you do so many homework questions, you can kind of get lazy. It's like, am I going to really write these bars on every single one of the vectors? I mean, I should. In fact, there should be some delta t's in there, but so sometimes the notation gets sloppy, but make sure you account for the vectors. So we have a positive 100 displacement. What can we do with that VI? And that's a very common thing. That's a very common thing. They give you an initial velocity of 0, and that whole term just sort of vanishes. Why does it vanish? Yeah, 0 times anything is 0. So then all you're left with is this 1/2. I'll go back to black. Got this 1/2 AT squared, but we know A. So A is 1, and then we got this T squared. I mean, 1/2 times 1, that's just 1/2, right? So you got 100, 1/2 T squared. How are you going to move that 2 to the other side to isolate the T? Times by 2 on both sides. So then you have 200 equals T squared. And then, of course, how to get rid of this square root 200. So the square root of 200, oh my gosh, 14. Are we rounding down or rounding up for 2 significant digits? Final answer 14? seconds. So I think if we just do this for about 10 minutes or so, you can get some practice with me, and then I'll let you guys try some more of your homework. Good? Good. So just as a heads up, when you take Physics 30, you have to know these kinematics. It's like certain things always carry over to the next course. This kinematics equations is one of those things. Like, you got to be able to use these. Like, you'll be talking about a charged proton like moving through an electric field or a magnetic field, and you'll have to analyze the accelerations and the displacements of those particles. So This is an idea that will carry forward into Physics 30 if you plan on taking it. Times by 2 on both sides. 100 times 2. Because it's 1/2 on the right. Times 2 on the left. Okay. An airplane is traveling at 100 meters per second. So for this one, I'll ask you to just draw a quick picture. If the airplane is the dot, guys, if the airplane is the dot and it's traveling 100 meters per second to the right, and you want it to speed up, which way would the acceleration vector have to point? Yeah, to the right. So that's a way you can instantly tell, okay, both of those vectors are positive. So when they go into my equations, they go in as positives. Let's jot down what we know. The VI is 100. The A is 1. The distance is 200. Now we're looking for T. So T is the question mark. So for this one, which variable do they not tell us anything about? They don't tell us about VF. So VF is like double question mark. If time is what we want to know, and they don't give us VF, what can we use? This one, right? But there will be a problem. So what's the problem when you try to use this one here? Guys at the back, you following along? What's going to happen is that because VI is not 0, that doesn't just disappear. And then you have two variables, a quadratic, that I think most of you don't probably have the skills yet to solve. Okay, so what you could do is you could put this stuff in. 200 equals 100t plus 1/2. A is 1, so you have t squared. That type of formula is not a linear equation. This is a quadratic equation. It's degree 2. So to solve these, what you do is you put them on one side. So you have, let's reorder them so it looks more like you'd see it in a math class. You have something like this. So you could put this in your calculator. You could put this in y1, and you could solve for the zeros if you know what I'm even talking about. You've had to have taken 20-2 or 20-1. Right. So is there a way in our physics to get around that? What could we do? Yeah. Find out VF first. So find VF first. Okay. So which formula could we use to find VF? Yeah, this one here. This is a really nice one. Okay? This one here. So we got, I'll switch color now. It says this is like I've switched gears and I'm thinking, I'm planning, and I'm like, this isn't working, so let's find VF first. So I got this VF square equals VI square plus a 2AD. And then we can put in 100 squared plus 2 times 1 times 200. Okay. What does that equal to? The right side. 100 squared plus 400. 10,400. Then we got to square root that sucker. And I get 102 after rounding. Okay, so I'll switch colors again. So now that we have the VF, we got VF, we got VI. What else do we have? We have A. Whoa. We have A, and we want T. We want T. Yeah. Sometimes some are easier than others. Like, always check to see if you can use this one. This is a nice one. This is a nice one. Just the standard formula. A is equal to VF minus VI over T. To solve for T, we would have to Frank, you with us? Alright, so these T and A will cross multiply switch. And A is 1, so it's quite nice. It's just VF minus VI. Since A is 1. So you're looking at about 2. If you kept your rounding, I think you get like 1.98. But that'll round up. It's 2 seconds. It's 102, take away 100. Should be 2 sig digs though, so 2.0. Seconds. Okay, so now I've given you another technique. If this VIT doesn't cancel out nicely with the 0 initial velocity, you might have to do a workaround. You might have to try another equation to get access to another one. Okay, starts from rest. If you see starts from rest, like, it does really simplify the problem. So let's list all the variables on the left. Figure out which equation you're going to use. Which variables are listed and which formula have you chosen? So which one you guys want? First one? This one? Oh, good. Worse than me. I saw a head nod. This is good. Jot it down. That's what I would always do. VF square equals VI square plus 2AD. Now at this point, you have choices. You can just solve this algebraically, or you can just put in numbers and solve that. Okay? So don't feel like you have to do this just with symbols. So if you just put in what you know, oh, that's nice. What happens when you go 0 squared? 0 squared is 0, so you just have 2AD, which is 2 times 1.5 times 250. And that equals VF squared. So what do you do once you times that right side? I think most people know that, especially with so much practice with Pythagorean theorem in junior high, that most people remember that strategy, the square root. 27. 2 sig digs. It's a speed. It's a vector. It's a velocity, pardon me. Do we need a direction? Well, everything's positive. So it started at rest. It's kind of implied. It would accelerate in the same direction as the velocity final. Let's keep going. Now we can try one that has just a little bit more of the algebra involved. So Mike, the driver here, he's going 10 meters per second positive. He pushes on the gas to accelerate, so his acceleration is also positive. So he should speed up. His final velocity is 17. That makes sense. How far did he go? Notice no mention of time. If you're, and this happens so often, if they don't mention time, like this is the one right here. Okay? It is a very common formula in physics. So we jot it down. And just as a nice strategy, you can identify which variable you're trying to unlock. So I give it a quick highlight. I want to get that variable by itself. So you kind of have to think in steps. First, I need to isolate 2AD, and then I can isolate D. So how do I first isolate 2AD? You got to get rid of this guy. Get rid of the VI. Now this is where students without much experience tend to make mistakes. They might want to divide out VI squared here. Good. We want to subtract. Okay, it's a term separated by another term with a plus or a minus in between. You have to first move one of those terms to the other side and just put on the opposite sign. I'll put in the numbers first, just to show you that you don't have to mess with variables. You can just plug in the numbers first. 289, 100, and 4D. Now you're looking at an equation that you probably did tons of work in junior high. Like, these are those multi-step equations that they practice in middle school. Lots of times you'd like draw the arrow or the line down the equal sign like this. You guys remember doing that? So really, like, I know you guys can do this. So again, like, you want to isolate for this letter here. You want it to be alone. I'll leave it on the right because it's already on the top. On the right, I'll leave it there. I got to isolate the 4D first, so move the 100. So how would you get rid of that 100? Minus the 100? All right, beautiful, you guys. 189 is 4D. Now what? Divide by 4. I love it. I love it. 47.25. How many sig digs? So we'll just go 47. You have a question about the work?
Yeah. I got 189 for D.
Oh, you just need a bracket around yours. Yours would work if you remember to do this. Oh. And you need a bracket on the bottom too. Yep. Okay, so hopefully there's a homework that comes up next. Yeah, because I gave it to you yesterday. So now you're going to finish this off. So I would say on level of importance, if you're taking Physics 30 especially, that getting good at this homework, very, very important.